So, so we say that indexing definitely can improve performance. The thing is that we should be careful what it is that we are trying to optimize, right? We're not necessarily trying to optimize, minimize the number of comparisons with the indices. That certainly is the case. Definitely, we want to minimize the number of comparisons, of course, right? But there's things that are even more expensive than iterating through this structure, right? The most expensive thing in a database operation is the fact that the database software, right, needs to eventually go out to the file system and read these records. It needs to go and read these records from the file system and bring them into memory, right, and then do the iteration and comparisons until it finds something, right. That is the single biggest operation, most expensive operation for a database, doing file I/O, right? So definitely that's what needs to be minimized, right? And that's what needs to be optimized. So let's take a look at that. Let's use a select statement that uses one index or a unique index and a non-unique index, and see how it compares, how they compare if with these values, right? So imagine we had a university, we have 40,000 students, and we have 40 departments teaching at the university. So let's say that there are on average there are 1,000 students per department, right? Making a total of 40,000 students. Now imagine that these records are stored in the database in various disk blocks, right? We say that each disk block can fit 10 different student records, right? So 10 students records can fit in one single disk block, and a disk block is what the minimum amount of information that a database will read every time that it goes out and in and out of to the file system. In one single file I/O, right, it reads 10 student records into memory. Okay, so these are not unrealistic numbers. These are fairly standard. They represent some reality, right? So knowing this, let's go back and look at the queries and compare it against an index and a non-index query, right? So for instance, when we were looking for the student using the primary key, right? For the worst case scenario for a non-index table, I had to loop 40,000. I had to go and read 10. Remember this. There's 40,000 students, then 10 students per block. So I would need to do 4,000 reads, right? I would need to read 4,000 times. I would need to go out to the file system and read this into memory to compare. So the non-index cost, right, is that there's 4,000 reads. Whereas if I am using the index, right, it would only take me a couple of reads, right, that to go and find the index, right, to go from the index to the record ID, right? Because again, it's a tree. The tree it's a much smaller structure that I can store, and I can very easily traverse from the root down to the leaf of the tree, right, and jump directly where the record is, right, and find it in the block, in the file block. So it might take me 3-4 reads, right, to read the blocks from memory. Once I've identified what the record is, it would take me an additional read to go from that reference to the actual record that I'm referencing in. So let's say that it takes me on average 3 reads in total. So to go from a non-index to an index, worst case scenario, right, we're looking at a 4,000 divided by 3, right, the ratio of 1,300 times faster performance, right, of using index versus non-index. Now, don't get too excited. This is not always the case. It depends again on whether you're using index, unique or non-unique indexes, and what is the ratio of how many students there are per department, how many departments there are. So those kinds of things are also play into this. So here's graphically, more or less, here we have 40,000 records. We know that these 40,000 records, there's 10 records per block, right? So in total, there's 4,000 blocks, right? So we have 40,000 records divided in 10 records per block. So there's 4,000 blocks here. Times 10, that's 4,000. And so here's for instance, there's block 100 might have 10 records, block 101 has 10 records, and so on and so forth, right? I would need to, in linear search, I would need to read the block 100 and go through each one of the 10 records in there, then read block 101, and then read through the 10 records in there. And as I am reading, I am comparing what I'm looking for and comparing it against the field that I'm looking for, right? Until I find it. Now, so let's take a look at another example, but using the non-unique indexes.